there, mathematicians, it's Justin again. I am so glad you're here. Mia and I are mining for mathematical solutions, but for some reason, we're getting different answers to the same problem. Can you help us? This is the problem we're stuck on. 4 plus 6 divided by 2. I started by adding 4 plus 6 to get 10, and then divided it by 2 to get 5. But Mia started with dividing 6 by 2, which equals 3, and then added 4 to get 7. Weird, huh? Neither of us made any calculation errors, so how did we get different answers? If there could be more than one answer for a problem, how do we know which one is correct? I think I might know a sparkly little gem of knowledge that can help us out here. By the end of this lesson, you'll be able to recall the order of operations and explain why the operations are in that particular order. Have your guided notes ready, grab your pickaxe, and let's dig our way into the bedrock of the order of operations. Back to the mine. Mia and I solved the same problem, so why did we get different answers? Maybe it has something to do with how we solved it? Mia divided first, I added first. Do you think it matters which operation we started with? How can we be sure we are always solving problems correctly? We can utilize the order of operations. The order of operations is a set of rules that tell us the sequence in which mathematical operations should be performed. Operations are the actions we perform in math, such as addition and subtraction. Can you think of any other operations? Pause the video while you brainstorm and jot down ideas in your guided notes. There's also multiplication, division, exponents, and grouping symbols like parentheses and brackets. When solving problems with more than one of these operations, we follow a specific sequence or order. Remember the problem from the mine? I started with addition and Mia started with division. This must be why Mia and I got different answers. Let's discover what the right order is and how we can remember it. First, we always solve what's inside grouping symbols like parentheses or brackets. Then we simplify exponents. Next, we handle multiplication and division. And lastly, we finish the equation by solving any remaining subtraction and addition. Whoa, check this out. If we take the first letter of each of these steps, it spells the word gems. That's a neat way to remember the order. G for grouping, E for exponents, M for multiplication and division, and S for subtraction and addition. Now that's a useful nugget of information. Let's take a closer look at that problem from the mine. Using gems, can you determine which operation should be performed first? Based on the order of operations, division should always be performed before addition. When faced with a complex expression, like this, we might be tempted to jump right in and start working from the beginning. 6 plus 3 equals 9, times 1 equals 9 again, minus 2 plus 7, blah, 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 blah. But we're too smart for that trap. We have gems. First, we need to identify the operations involved. Take a moment to pause here and identify which part of the equation should be solved first. Always approach a problem by searching for grouping symbols first. Aha! I found a spot with a grouping. According to gems, I need to simplify what's inside of these parentheses first. 2 plus 7 equals 9. Remember to always bring down the rest of the unsolved pieces in the order they appear in the expression. With no more groupings left, I'm ready to move on to the next letter in gems, E for exponents. Do you notice any exponents in this expression? Ah, yes, right there. Exponents represent repeated multiplication. So 3 to the power of 2, or 3 squared, means to multiply 3 times 3. That equals 9. Bring down the rest of your expression, and with exponents out of the way, we are ready to move on to M for multiplication and division. Notice how multiplication and division are grouped into the same section of GEMS. That's because multiplication and division are inverse or opposite operations. For example, 2 times 3 equals 6, and 6 divided by 3 equals 2. Opposites. Multiplication and division are ranked equally in the order of operations, so we tackle them from left to right and solve whichever comes first. Here we have 3 times 1 and 9 divided by 9. Working from left to right, 3 times 1 equals 3, and 9 divided by 9 equals 1. Bring down any unsolved pieces of the expression, and this leads us to the final letter in GEMS, S for subtraction and addition. Like multiplication and division, subtraction and addition are inverse operations. For example, 5 plus 4 equals 9, and 9 minus 4 equals 5. Opposites. Subtraction and addition are ranked equally in GEMS, so like before, we work from left to right and solve whichever comes first. Starting with 6 plus 3 equals 9, and then 9 minus 1 gives us 8. Not too difficult now that we know the proper order of operations, huh? The order of operations is pretty handy, but you might be asking, why this particular order? Why solve groupings first and then leave subtraction and addition for last? Well, it's all about the language and logic of math. Parentheses or brackets signal us to isolate that section of the equation and solve it first. We handle exponents next because they represent a speedy way of repeated multiplication. Multiplication and division are next. They're ranked equally because multiplication is a faster form of addition and division is a faster form of subtraction. And finally, subtraction and addition are performed last because they're the most basic math operations and therefore have the lowest priority. So there you have it, GEMS. Remember the problem Mia and I were trying to solve at the beginning of the video? Despite correct calculations, the order in which we did them affected our final answers. If everyone solved the math problems in any random order, we'd all have different answers, and we wouldn't be able to agree on anything. Imagine the chaos if architects didn't use order of operations when designing structures, or if pilots used different methods of calculations for navigation. That's why mathematicians took a close look at the logic of math and found that there was an appropriate order in which to complete each operation. Now it's time to drill into our new skills and practice using GEMS. Let's solve the equation 10 minus 2 times 4 plus 1. Pause the video here and solve using your new understanding of the order of operations. According to GEMS, we start this problem with multiplication. 2 times 4 equals 8. Bring down the unsolved parts of the equation, and now we are left with subtraction and addition. Both are ranked evenly, so we work from left to right. 10 minus 8 equals 2, and 2 plus 1 equals 3. If you found this difficult, don't worry. We're going to practice solving many more problems using the order of operations in the next lesson. Thanks to our hard work today, you now know the correct order for solving problems with multiple operations. First, the grouping symbols, then exponents, followed by multiplication and division, and finally, subtraction and addition. You also know why the operations are in this sequence. It's based on mathematical logic. Be sure to complete the practice questions and extension activities that go with this lesson to learn more about the order of operations. Keep digging for more mathematical gems, mathematicians, and I'll see you next time.